But what Pascal's triangle is going to allow us to do is, if we understand the pattern that's involved, we can actually shorten some questions up a little bit. So here's how this works. Pascal's triangle goes kind of along with the Fibonacci sequence. What the heck is all this stuff? There are a lot of things in nature, sometimes with the rings of trees, a lot of times in flowers, the way their petals set up. I know you're probably not going to sit and look and count every single little petal within flowers, but things like sunflowers, for instance, actually have a pattern to them that goes along with them on the number of petals as they come out in the center. So, what this sequence actually does, Pascal's triangle, is whenever you work your way down, and it'll keep expanding beyond this, but for our purposes I didn't put it any further, but if you always take the two numbers above, you can add them up and they get the next number. So 1 and 2 is 3, 1 and 3 is 4, 3 and 3 is 6, and it just keeps expanding out and out forever and ever. But the nice thing about this, or kind of the cool thing about it, is not only is it just kind of a regular number pattern, but it's going to help us do some expansion when we have several terms that we're trying to multiply together. So for instance, here, if you kind of look at the triangle up above, you see, okay, at the top it's just 1. Anything to the 0 power is 1. That makes sense. If I had a plus b to the first power, well, it's just a plus b, Hardy. Right. Again, look up at your triangle, it's 1 and 1. As you start to move down, though, if I were to FOIL out a plus b squared, okay, do up a plus b in an a plus b box, I'll get a squared plus 2ab plus b squared. Notice up the triangle, 1, 2, 1. If I did a plus b cubed, so like yesterday when we spread this out, FOILed the first two and then did it again with the box, 1, 3, 3, 1. Just like the triangle you see up above. So this pattern starts to develop. But there's a second pattern in there that we didn't talk about yesterday that might come in handy. As you start to look at the variables on these, you're like, okay, so I got a to the third. The next term goes to a squared, then to a, and then there's no more a's. Well, if I look at b, the first term doesn't have a b, then I have b to the first, b to the second, b to the third. So when you start to look at these, your first variable term, a to the fourth, 3, 2, 1, a to the 0 basically is what I'm seeing here on the end. And just goes the other way as 2. This is like b to the 0, 1, 2, 3, 4. So you're like, well, why do I want to mess with this pattern? Because if sometime, let's just say, for instance, I asked you to expand something like x plus 3 to the 5th, do you really want to do a box, and then do a second box to get to the third, and then do a third box to get to the fourth, and do a fourth box to get to the 5th? That's going to be really, really time-consuming. So understanding how this works might make this go a little bit faster. So here's how the pattern's going to work. When I get down here, so I'm going to kind of look at it as this a and b, just so I can see how it fits into the pattern. My a value here would be my first term, which is x. B is going to be my second one, which is 2. Now you're like, couldn't I just FOIL that out? Yes. Yes, you could. You're like, if this is the answer I'm getting, and I look at this, and I'm just like, well, why wouldn't I just do x plus 2, x plus 2, just like we did yesterday, and fill in all the boxes, and then combine my like terms, I get the same thing. Why can't I do it this way? You can. You absolutely can. And for squareds and cubes, for some of you may choose to go that route. I'm not going to tell you the way you have to do it. I'm just going to show you some options. Because if I use that same thing, but I used my triangle, basically what I would do is I would take each of the parts, so a squared, y is x, so x squared, plus 2 times my a and b, so 2 times x and 2, plus my b term squared, plus 2 squared. And I just simplify it. Same answer, different ways of getting there. It's the same thing in example 2. My first term is x. My b term is at minus 3. And I would do the same thing. Square my a term plus 2 times a times b plus my b term squared. Whether I box it out, FOIL it out, or use the pattern, I get to the same place. The place that you'll start to see it come in a little more handy, though, is as we work down the triangle. Now I get to cubes. Could I sit here and say, okay, so that means I got 3 of these. Can I, if I choose, take them 2 at a time like we did yesterday? I know this is my x, this is my a and b. Could I sit here and say, okay, I'm going to do a 2 by 2 box here. I'm going to multiply this out because, you know, it's kind of comfortable and I'm good with it. I get my x squared. I get my 8x and my 16. But then I have to take that. I'll build a box right off of it. And do it one more time. Because again, it's to the third, and I've only dealt with 2 of them. So then I start filling this box in. I'm multiplying, and I'm adding my exponents, and I'm going, okay, I'm glad I don't have to do like 30 of these. This is kind of taking me some time here. Rather be off on Facebook seeing what the latest drama is. Yeah, I just said that on my own YouTube channel. Oh, gracious. This is not in any way promoting drama book. Okay. So you notice I get the same thing. Okay? Here's my answer using Pascal's triangle over here to the left. Here's my answer doing a box and another box over here. Same thing. Okay, so it's not like I don't have an option. But isn't it kind of faster if I look at the triangle to say, okay, I'm going to bring this back down a little bit. Oh, no kidding. Really, Hardy? 4 cubed is 16. Oh, more YouTube issues for Hardy. Okay, so since those are the same, what I could do, okay, because way at the top of the screen, there's my cube. So I cube my first term, so x cubed, plus 3 times my first term squared, which is the x squared, times b, so 3 times 4 is 12, x squared, plus 3 times x times my b term squared, my second term is 4, so I'd square that. 4 squared is 16, times 3 is 48, plus my b term cubed, which is 4. 4 cubed is 64, not the 16 that you originally see on your sheet. Yeah. Okay, think about this for a minute. You could actually even build this if you needed to. Actually, let me put the paper on here so you can see. So let's say I said, okay, you're going to do a test. You're like, I like this triangle, but I'm going to forget something. So let's cover this up for a minute. Pascal's triangle always starts with 3 ones at the top. Okay? Once I get there, there's always going to be 1s on the outer edges. So I add 1 number. Here's a couple. Add those 2 together. Okay, I get 2. I'm always going to have 1s on the outside. Add these together. I get 3. 2 and 1 is 3. 1s on the outside. Add what's in the middle together. And just keep adding them and working your way down. So the numbers in here, because there's still one more piece I'd have to deal with. Did I do? Mercy. Oh. Okay. Thank you. So yeah, 10. Otherwise, I just messed up Pascal. I just messed up nature. So when I get here, though, here's the other part I've got to keep in mind. I'm always starting with A and going over to B. So then I've got, you're like, well, wait a minute. So my first term here is squared. Then it goes down to A, and then I don't have any A's left. This one starts with no B. My first B, my second B. If I can get the numbers here I start with my third level. So I start with A cubed. I go to A squared. Then I go to A. Now I don't have any A's left. So here, right, here I have no B's. I get a B. Now I have 2. Now I have 3. And it's always pluses in the middle, so at least you don't have to play with signs on this. So then here, I'm on the 4th level, and I can always tell by the first non-zero digit I see. So I start with A to the 4th, and just go down. 3, ooh, I almost did B. 2, 1, my last term won't have 1. Now B, if you just wanted to go the opposite way, you could go, oh, so this is B to the 4th, B to the 3rd, B squared, B to the 1st, and then I get with A. And you start to literally see where it's building from, where it's given to you. Start with A to the 5th, count down, 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 down. But B starts at the other end with 5. Down, 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 down. Okay? So it does. For those of you that really want to be able to save time, kind of looking to see where this pattern develops helps. The really cool part about this is when you end up getting, and we'll see this in a little bit, I may ask you to find a third term of something. So you're like, do I really want to do all of this work just to find one term? If I know the pattern, I don't have to. So let's see if we can do it here. So I've got x, and I've got -2. So look at your triangle and kind of think and go, okay, so this is going to be, since I'm doing a cube, a to the 3rd plus 3a squared b squared b cubed. So again, the a's count down as I go to the right. Okay? My b's count down as I go back to the left. And again, even just drawing the triangle with the numbers at the start, if you need to at the top of a quiz or a worksheet or a homework assignment, it's probably a good way to go. Because once I know this, now I'm just substituting. X goes in for A here. X goes in here. My B is -2. A is X. -2 squared. And my B is -2. And then we just simplify. -2 times 3 is -6, x squared. -2 quantity squared is +4, times 3 is 12. -2 is 8. If any of you went ahead and went double box on that, you'll get the same thing. And that's fine. If you want to go ahead and do the boxes because you like something that's more consistent that you can use each time, that's fine. It's just going to take a little extra time, but no big deal. Yeah, absolutely. Everybody's got their own way. I just like giving you options. So, if you flip over, here's where life can get a little more interesting. Sometimes you may get some twists with values going with your variables. So for instance, I'm even going to jump to the crazy one first. Let's go over to 6. When I'm looking at this, if I'm doing the pattern, my A value is 3A, My b value is negative 4b. Now, some of you may say, well, that's squared, so I'm just going to box it out. Okay, if you went that route, I just have 3a minus 4b on each side. Sometimes you may find the box might be an easier way, but be careful. Only add your exponents when they're a like base. So a and a gives me a squared. But when I get to the next box, negative 12ab. Okay, can't add exponents, not the same base. Here again, negative 12ab. Can't add them up. Here, negative times negative is positive 16b squared. So if you want, on squareds for a lot of you, this may be the best option. But when you get to cubes with the same thing, so once I get past something like number 6, and let's say I'm heading towards example 7, now it's a cube with, a and b in there. Ugh. Here's where I would kind of push the idea of, instead of going to the pattern, going here. So I remember two things about this. And here's why I think 7 is going to be easier with the pattern. First thing I know, my a would be 2a, my b value is 5b. And I know since it's a third level, I know the pattern goes 1, 3, 3, 1. I also remember that since I'm on level 3, I start with a to the third. Now I'll put it again. A squared, a, and then I run out. And my b's just start at the other end. B cubed, b squared, b, and then I don't have one. So just by understanding the numbers, I can recreate that line of the triangle for what I need it for. Because I really think once you get here, you're all capable of substituting. Yeah, that should be an a squared. I started to make b, and I'm like, no, it's not b. Yeah, you can still, on this, because some of you are saying, can I still do my double box, where I do my box, and then I box it? Yeah, you absolutely can. No, but as I'm going to keep saying, if I expand this up sometime to the 5th or to the 6th, you really want to do 3 or 4 separate boxes, is going to be my question. That's something you have to consider. So here's the first question. Do we see where this is coming from? That's the big thing right here. If you see where this is coming from, all I have to do then is say, okay, this is my first term, so it's 2a cubed. Then when I get to my second term, my first term squared, my second term. Then I just keep moving along. My first term, no exponent this time. And my second term squared. And then my last term cubed. You're like, really, Hardy? This is the shorter way? It is, actually. Because now, again, that cube goes to the 2 and the a. So 8a cubed. Like here? No, because we're actually substituting. This is just my form of sorts, and I'm literally taking these values and plugging them in for that a. So it's sort of like if you have 7x plus 1 and I tell you let x equal 5, you're taking the x out and you're literally plugging the 5 in. That's what we're doing here. We're literally substituting. So 2 squared is 4. 4 times 3 is 12. Times 5 is 60. A squared b. 2 squared, let me do it up here. Let me do a little side work. Okay, little side work. 3 is still here. If I square this whole term, that's 4a squared times 5b. 3 times 4 is 12, times 5 is 60, and then I have an a squared and a b. 2a, quantity squared, means the squared goes to the 2. 2 squared is 4a squared. 2a times 2a. 2a squared just means this. Okay, now I just multiply the coefficients together and add my exponent. And I'm going to do that same thing on this next part. Again, if you need to do side work for this, that's not a problem. Because here, 5 squared is 25. So 25 times 2 is 50. Times 3 is 150. A, b squared. Again, the squared goes to everything in the parentheses. And then here, 5 cubed is 125. B cubed. Again, some of you keep asking, can I just do 2 boxes? Yes. Yes, yes, and yes. Alright, let's see what's up here. Alright. Already on the quick double box, just in case for our boxing fans out there. So let's see what's going on here. So if I combine my like terms, okay, because yep, you will, just to let you see, you will get the same answer either way. But for some of you that are starting to see my pattern developing here, well, actually it's not mine, it's Pascal's, but there's even issues with this, because I mean, I've got to watch what variables are in here to make sure that I'm not getting things mixed up. So I mean, they both have their good qualities, but they both have some issues too. This is a little more time consuming, and there's also more opportunities to make an error somewhere. But I've got my 8a cubed. What's that? So if these two are the same, 20 and 40 is 60. 150 is 150. And there's my last term. So I got the same thing. It's just dependent on how you want to tackle it. So again, just comes back to a choice. But here's where I really think understanding the triangle helps. When you get down to the bottom here, what if I have a question like, find the second term in the expansion of the quantity 3u minus 1 cubed. In other words, if I ask that in example 7, this is the only piece I want. If I understand the pattern, this is going to go a lot faster. For instance, here, my a value would be 3u. It's just my first term. My b value would be negative 1, or just whatever my second term is. So if I understand the pattern, if I can recreate this, all I have to do is plug the values into this. I don't have to do all of it. So if you're doing the double box, you have to do everything. If you understand the pattern, now I'm just going to take the 3u, I'm going to plug it in where a goes. I'm going to take negative 1, I'm going to plug it in where b goes. And I'm just going to simplify it. I'm going to be done, and I'm going to circle it, and I'm going to go, woo! But, let me show you how this works. On the one where it says you try, okay, third term in the expansion of x plus 4y to the third. Remember, third level, I'm at 1, 3, 3, 1. start with my A. I'm going to do this clean this time. Work my way down until I run out of places to put A's. 3, 2, 1. I have no A's left. With the B's, start at the other end with your cube, squared, 1, then I run out. So I created my pattern. I'm not having to memorize it necessarily. If I just understand the numbers, I can figure this part out. So now, my first term, my A value is X. So whenever I see A, I'm going to put an X in there. Whenever I see B, I'm going to plug a 4Y in. But do I need to plug it in everywhere? No. The only place I need to plug it in, I'm being asked for the third term. This is the only place I need to plug it in. But this only works for me if I understand and know the pattern and use it. So I'm going to do 3. My A substitute is X. My B substitute is 4Y. And now I just multiply this out. So I'll clean this up first, because I think before when I skipped that step, some of you I lost there. So 4 squared is 16y squared. I squared the 4 and the y. And now I just simplify this. 3 times 16 is 48, xy squared. There's my third term in the expansion. Otherwise, I have to double box this and then go looking for the third term. You can. Not saying you can't. I'm just saying it's not the shortest distance between two places. Okay? So your job, depending on how you want to take it, is to deal with that worksheet to get some practice at this. So whether you're getting practice at doing your squares or playing with the pattern, it's a nice thing to be able to do. And if you get done with the sheet and you're still kind of, okay, make up a problem. Shoot, come see me. I'll make up stuff. And we'll kind of see if you've got the idea of this or not.